Hi everyone, welcome to Sachii Online Academy. This is Ezekiel. Today we are going to do assembly language and we'll be using MIPS, which is millions instruction per second. If you are new to this channel, just click the subscribe button below and don't forget to turn on the notification bell so that whenever I upload a new video, you get a notification from this channel. And if you have already subscribed to this channel, just enjoy this video that I have done for you. So I'm not going to start by explaining more deep into the assembly language, but I think you all know that the assembly language is just the low level language, which is nearly to the machine language. And we all know that the machine understands its own language, which is the binary language. Okay, mostly the binary language. So here we'll be writing the code most nearly to that language, okay, which is the slightly higher level language, but it's most likely the like the machine language, which is zeros and ones. So here we'll be actually put our code, or we'll be programming the registers. Okay, so we have got the register set that we have in MIPS, and this register set comprises of 32 registers, and of which 31 of them are general purpose registers that we can use with any instruction. Okay, with any instructions that we have in a MIPS. Okay, also here though we have got 31 general purpose registers, they are not used the way that we think, because here some programmers, guys, have actually agreed or put some guidelines on their code, okay, on how they are going to use this general purpose register. So when you see these 31 general purpose registers, you are going to see with specifically the way that are going to be used in our code. Why? Because there are some guidelines that we put together, guys. Okay, so here let's jump into our register set. Here I've got the 0 register, and the number of this register is 0, and it will contain a constant 0. That's its usage, guys. And then we have got the 80 register, and the number is 1, which means we've got 0, 1 up to 31. And if we add that number, we get 32. Okay, which means they all of them, they are 32, okay, in total. And then here is register number 1. Okay, for all information, they will be looking like this. Do I have? Oh, okay, I think I have zoomed it out. Okay, never mind, let's continue. Here we've got the register V0 here, guys. So we've got the register V0 up to V1, and its number is 2 and 3, register number 2 and number 3, and these are result registers, which means that's where we store our results. After a certain operation, we store our result in V0 and V1. And then we've got the argument registers, which is A0 up to A3, and then we can add from register number 3, which means register A0 will be the register number 4, and A1 the register number 5 up to A3, which is the register number 7, and they are called argument registers. And here in this argument register, that's okay, I do not go deep here now. And then we've got the register T0 up to T9, and then these are registers from 8 to 15 and 24 to 25. And these are temporal registers. They are called temporal registers, and they are from $T0. They are from T0 up to T9. And then we've got the saved registers from S0 up to S7, which means S0, S1, S2 up to S7. And then they run from 16 up to 23. Here it's 8 up to 15, and then 24 and 25. That's their number. Here is 16 up to 23. Okay, and then K0 up to K1, which are kernel registers, which is 26 and register number 27. And then the GP, which is the global data pointer, and then the SP, which is the stack pointer, and then FP, which is the frame pointer, and RA, which is the return address. Okay, and then that's the final register that we have. And now guys, let's move on to how do we use these registers, which means we are going to dive into a simple code, guys, showing you how are we going to use those registers. But before we go there on how to use these registers, guys, I want to talk about labels. We've got what we call labels here, okay, which is just a simple name, guys, that we use to refer to a certain maybe to a certain memo, to a certain string. These are labels that we use to refer to a certain procedure, okay. That's a label. It's just a simple name, like the way we name our variables, okay. We give it a label so that we can call it. That's the name. We can have a main as a label, just a main as a label, okay. And we have to know that main, that's where our program starts, okay. And then we have got what we call syscalls here. Syscalls is like we'll be transferring the program execution, or the control, the program control, to the operating system. Then the operating system will act accordingly. So here I'll be showing you step by step where we are doing the coding, okay. Here we'll be actually doing the coding. So I'm going to give a simple example of a simple code, just a simple code that I'm going to do with you. And then while in the process of doing that code, I'll be explaining to you guys these registers, how are we going to use them, and also the instructions that we are going to use, and like load immediate value, load address, load wait, all those instructions, the control, the flow control instructions, jump, branch if less than, branch if greater than, all those ones. We are going to do them. But for now, I'm going to do, as an introduction, I'm going to do a simple code. Okay, so without wasting much of your time, let's see what we have here, guys. We see here, guys, we have got this dot data and dot text. Here the dot data, that's where under dot data, guys, it's a segment, guys. That's where we put, or we save all the data that we want to use in our code, okay. And then here we have got dot text. Here with the dot text, that's where we put that's where our program starts to execute. That's where we put our instruction that we want to execute, guys, under dot text. So here it's like we save the data in memory under dot data. That's where we put the data which will be saved in memory, and then we call that data inside the dot text. So here, guys, you see we have LI, which means it's load immediate value, and then here we have got $T1. T1, as we are talking, as I said that guys, this is a register that we have, which is $T1, and then you have got a 1 here, which is an immediate value. So here it's a load immediate value. We are loading a certain value into T1, and then here you have got the value 2, which we are loading in $T2. You have to know that, guys, how do we write our registers here, guys? We write our registers by preceding it with a dollar sign, okay, which is $T1, $T2. All those registers that we are talking about, guys, we have to put a dollar where we are writing our simple code. And here I'm using mass, guys. So here, guys, after loading this, we want to add, guys, we want to add 2 registers, and then we display the result. That just as simple as that. That's the code that we are going to write here, guys. And then I'll run your code here, guys. So here, these are our registers that we have here, guys. It's $0 up to here, which is the low register, up to the return address register here, like the way that, like what I have showed you, guys. So here it's 0, 1, 2 up to register 31, and then all these registers are 32 registers, as you see here, guys. I think this is the thing that I was showing you here, guys. And then these are our registers here, guys. So if I say $T1, you see here, guys, we have this general purpose register that we have the temporal registers, $T0, $T1 up to $T2, just going down up to $T7. those registers are the one that I was showing you guys. So guys, without wasting much of your time, I've showed you here guys. I have loaded an immediate value in $T1 and I have loaded another immediate value in $T2. Okay, and then now I want to add this value. These are values. Okay, here with the add instruction, I will use the add instruction here to add this. And you see here guys, we have this one, the first one, which says we can add 2 registers and we store the value in what, in another certain registers. Okay, or you can add here an immediate value, okay, with another register, and then you store a value here. So for me, to make it easier, let me say $T0. I will explain here guys, and then I will say $T1, and you put a comma. We use a comma to separate our registers, and then I'll put $T2. Here I am saying it's just like if it is the code that we used to see in a C language, it's like, or in any higher level language, it's like I'm saying $T0 must be initialized $T1 plus $T2. It's like you are adding this register and this register, and we store our value in T0. The first operand, or the first register or register, is going to be our destination register. That's where we store our result. Okay, and then after that guys, I want to display this result, but because I want to display this result, which means I have to call the operating system so that it can actually print the value to the display, print the value to the screen. So we use the system call. I think you have I mentioned that earlier guys. What do we use a system call for? A system call, we use it to transfer the control from the operating system to the operating system, from our program to the operating system. And then the operating system will act accordingly. How? By looking on the value in the argument register here, argument register 0. So we have to put something in our not in the argument register, I mean in the $V0 in V0 register. It will check the V0 register. Where is the V0 register? Here it will check this register, the V0 register, and then it will act accordingly, according to the number which is in that register. So you have to know that when you want to display an integer, which value do we have to place in $V0. Okay, so here I want to display my answer. Okay, so here, how do I display my answer? Here I have to say I have to load first. I have to move. Let me use the move instruction in argument register, because whenever you want to print something to screen, you have to first load that value in the argument register. So where is our answer? Our answer is in $T0. You see, so we take the answer that we get here, and then we put it in our argument register, which is argument register 0, and then we want to display that value in argument register. So how do we display that value? Now we load the immediate value in what? In $V0. Whenever you want to load a certain value like 1 2 3 4 0, which is an immediate value, you use the LI, load immediate value. Okay, so I want to load the immediate value, which is for printing an integer. I think it's 1 for printing an integer. I think it's 1 for printing. Okay, and then you have to say do it Cisco. Okay, then Cisco, just do it. So whenever program encounter Cisco, it will transfer the operation to the operating system, and then the operating system will check the value which will be in $V0, and then it will see it is 1. Then it will do the procedure needed whenever it sees this one. So here it will display the value in 0. okay, because this one is for printing an integer. So let me run this code and see what do we get. Then assemble. No, why do you want to say open? I don't want to open this. I want to assemble this code and then I want to run it. So here, as you see guys, we have got a 3 here as our answer. This is 3 here as our answer. So as you see here guys, we have say 1 plus 2 and then the answer is 3, and then this answer we move it in $A0, which is our argument register. That's where do you put everything that you want to print to screen, okay? And then we load the immediate value, which is like an interrupt or a system call that we do guys to print an integer to the screen using a 1 there guys. And also here guys, maybe you can do this guys, can also do this. We can print this thing that we have here guys. This is a string guys. Here I'm going to show you how to print a string here to the screen. Like we want to say the answer is 3, okay? So here firstly guys, you define your string in the data segment. Here in the data segment, so here you put how do you define your string guys? You put the label first and then you put the full colon and then you say dot ASCII z, okay, which means ASCII 0. It will be terminated by a 0. It's just an ASCII or it's just a text, okay? And then you put it inside these quotes, okay? And then you say the answer is, and then we don't terminate here guys. And then in the text here guys, we have to load the address here first, but where guys? So you have to load the address in, so I don't think we have to do it here. I think we have to do it here guys. So I have to load the address of what in what. I have said everything that you have to print to screen, put it in A0, okay? So let me load it in A0. And then its label is answer, okay? This is the label. I'm loading the address of answer here because it is in memory. It will be in memory, so I load the address of that memory into A0, and then I'll perform a syscall, which is syscall 4 for printing a string. And then I'll say load immediate value in $. We said for a syscall we put our things in what, the value of syscall we put it in V0, and then I'll put 4 here, and then I'll perform syscall, okay? When I perform this syscall, it will display the answer is, and then it will come here after performing this syscall. It will come here and moving our answer here from $T0 into A0 guys, okay? And after that it will it will put 1 in the $V0, and then it will do a syscall. So let me assemble this code and then run this. You see here guys, the answer is 3 guys. So I have to say thank you guys. This is how do we use our registers guys to write a simple code guys. This was just an introduction to MIPS guys. This was just an introduction to MIPS. How do we use our registers? How do we use some basic instructions like load immediate value, load address, move. Also guys, this was how do we add 2 numbers, how do we display an integer, okay, how do we display a string. I think we've covered all those things in this tutorial guys. So I have to say thank you for watching this video guys. Don't forget to put your comments guys in the commenting section, so that I will know what do you want me to do next, and also I know what do you want me to improve on guys. So if you like this video, just give it some thumbs guys. So I have to say share this video guys with your colleagues guys. So I have to say thank you for watching this video guys. Have a nice time.